talk about some more Splunk. So here we are. Now, the way this course works, just to keep people moving, I put in the timeline that you should turn in 20 points of BoTS for the first 4 weeks. That doesn't mean you have to get them from the section called 1, 2, 3, and 4 or anything. So you could do just another 20 points over what you had before, or more, is all I care about. But I'm demonstrating them in these orders. All right, so section 2 here. Section 1, for example, section 1 here had 35 points. So you could do the... All right, anyway, hopefully you've done at least 20 points of these, and you do kind of need the answers for 2 and 3 to move forward. You need to know the IP address of the attacker and the IP address of the web server. So I saved that from last week. Down here, there's the web server and the attacker IP. We're going to need that. So now we're going to find the staging server's IP. Now, we found the domain name. And so in this case, I remember it was jumpingcrab.something or other. The domain name used to perform the attack. And I think I'll start by just repeating that because that's good to see. So if you do HTTP events, which you can do here, data summary. Yes. All right. Go to source types, and down here somewhere is HTTP. There it is. All right, so if I run HTTP events, and then I put in the domain name, I'm really not Batman. .com. All right, and then for the moment I'm going to put in some sampling and search for all time, because there'll be a lot of these. Okay, and I'd rather see it in list form. Okay, so now I got 214 events of HTTP type. And if I just look at them, they're probably mostly attacks. Yep, here it is. This was an attack. It's coming in from the Active scanner. So this is coming from the attacker. So I've got, now I wanted to find the traffic that went backwards. So from this one event, I find the name of the scanner, I find the attacker's IP, which is the source of this, and I find the server's IP, which is the destination of this. So this is the IP address of the web server. And to find the attack file name, I want to have traffic that came from the web server, not to the web server. And so for that, I want to filter by source IP, which I can do here. Client IP is up here. If I click on it here, there are 2 values. So I pick either value, it doesn't matter, just to get it to fill in the query for me. And now I replace that IP address with the IP address of the web server. Now, when I search, I find no events, for 2 reasons. One is I left sampling 1 to 100, so if there's less than 10, I'm not going to see any. And the other thing is I left the domain name in here, and the traffic coming from the web server does not have the domain name of the web server on it. So I'll get rid of that and turn off the sampling. And now I should find 8 or 9 events that went backwards through the network. And there they are, the 9 events that went backwards. And in these events, I can find the domain name of the staging server, where they store their malicious stuff for further downloads. So it'll just be down here, there, towards the end of this. There it is, prankglassinebracket.jumpingcrab.com:1337. That's the malicious server where they downloaded it, and here's the image they downloaded. So I'll just copy this and add it to my list of useful facts here to help me move forward. All right, prankglassinebracket.jumpingcrab.com. All right, those are, so now I can move on to the new stuff, which is you found the staging server's domain name, find that server's IP address. So they should look for get events containing the fully qualified domain name. Well, we've already got it anyway. Right here, it's in these, right here we've got the request downloading the malicious image. So we just need to know the IP address that this request went to. And source IP is the web server, and there should be a destination IP someplace. There it is, destination IP. So there is the web address of this server. All right, which is not equal to the one they ran the vulnerability scanner from. There. This is the staging server. All right. There's the domain name, and there's the IP address of the staging server. All right. Now, if I go to my instructions, all right, now I want to find the other domains on the staging server. And for this, you just go to Google and search for the IP address. This is a very common thing. See, what happens is bad guys will hack into a server or buy a server at a bulletproof hosting center that doesn't care, and then they will use it over and over again for different criminal purposes. So it develops a reputation. So now that I know that something bad was staged at this address, I might wonder what else has been going on at that address. So you can just Google the address. It's a good place to get started. And there are threat intelligent companies that just, what should be 23, I'm missing the first digit. There are threat intelligence companies that just record historical information about malicious servers. Alien Vault is one of them, and Virus Total and others. In this case, the Alien Vault looks pretty good. Threat Miner, IP Info, Hybrid Analysis, RobTex, these are all companies that publish information about malicious servers. In this case, the first one's probably pretty good, Alien Vault. This will show you what's been going on that server. And so this server had something called Wayne Corp Inc. And it had, there's one called poisonivy.com with numbers used instead of letters. And that's the one that we were looking for. This is, if you read the instructions, you're trying to find the LeetSpeak domain on that server. So this server has been used with several different domain names for different parts of attacks. So that's all you're looking for here. Now, this one is a lot of fun. There was a brute force attack. See, we noticed right now, this is actually very much good for the incident response class. The first thing we noticed was, of course, the defaced web server. They put an extra image on the web server. So we found the traffic that went backwards and the defaced web server. That is like the first thing that started the incident. But of course, that can't be the beginning of it, because how did the bad guys get to execute code on the web server in the first place? How did they get in order to run a GET request and put junk on the server? So we found an incident in the middle, which is what usually happens. They get in and you don't notice them. They do bad things and you don't notice them. Then they finally do bad things so bad that you notice them. The first thing you notice is not the initial attack. It's deep in the attack. And that's what happened to us here. So the next question is, how did they get in? And it turns out they got in with a brute force attack against the web server itself. So we're going to find the 15,000 events using the post method to go to I'mReallyNotBatman.com. So let's go to here. Oh, let me check for questions in the online chat. Nope, just discussion, which is fine. Okay, so here, I want HTTP, and I don't want it to be going from the web server anymore. I want it to be going to that domain again. I'mReallyNotBatman.com. Okay. That's going to be HTTP traffic going to the web server. I'm going to go to sampling again because there's going to be a lot of it. And now I want to get certain methods. Now, typically the only methods people use are post and get. So HTTP method should be down here somewhere. HTTP method. Okay, there's post and get. And I think here we want the posts because that's typically a login is a post. Yep, so we want, and there should be 15,570 of them. And 135, but I'm sampling. Let me stop sampling and see if I get that number. This is a handy way to know if you're on the right track. This is a very common, I was a database administrator for years, and you learn to always know how many records are involved with everything. You check that all the time to make sure you're on the right track. So let's make sure 15,560. And okay, I'm off by 10. I think I've seen this before. There's some minor variation. Anyway, so I found them. Now I want to exclude the events from the vulnerability scanner because that's not interesting, because that was not the brute force attack. So the easiest way to exclude it is just avoid that word Acunetics. Remember, you want a Boolean operator, you have to put it in capitals, and it will then turn orange. which it didn't, which is disturbing. I wonder if I've somehow turned off the color formatting on this machine. I'm thinking I must have, because that should have formatted. There's a setting somewhere to turn it off. Let's see if this works. I know if you use lowercase not, it will not understand it. Uppercase not, it should understand it. If this works, that number should go down, 15,560. A bunch of things should vanish. Let's see what happens. Okay, now I get 431. I think that's the right number. Yep, now, okay, I examine the form data, and this is the most useful way to do it, my favorite way to do it. So let's go to, if you go down here, the interesting thing here is the form data. There. The form data is there. And notice, start, limit, explore, get direction, content. Okay, some of the form data is not showing the interesting stuff. Let's just do it this way. We'll put in a table with time and form data, nothing else. Okay, the first couple are not very interesting, but before long we're going to see the attack, and there. Now here I'm seeing a bunch of login events. Username is admin every time, and the password is rock, cool, Sammy, August. This is a brute force attack. It's trying a whole bunch of passwords, logging in over and over, and it's going really fast. Here I am at 51.3 seconds, 51.1 second, 51.1, 50.87. This is several login events per second, changing just the password. This is what a dictionary attack, people typically call it a brute force attack. They're just trying many passwords to get in. And you can see the nice progress of the whole attack here. So you want to find the IP address performing this attack. Well, that would be pretty easy. All we need is any one of these events. So if I, it'd be any one of the ones down here. Now, I'd like to find a way to find just these events and not have these extra. There are a few extra login events that were not part of the attack up here. So one thing I'm finding, for example, is username equals admin. Seems to be in all of these. So if I add these, if I add this to the query, that should do it. I'll just highlight that and put it in here. There, that should get rid of the extra events. Okay, and now this looks really good. See, here they are. It's sort of interesting. They're not in any time order anymore, which is a little rude. I'm going to sort them by time. There, now I've got the 226. Now I'm going forward in time. 21.2, 21.24. Okay, here they are trying many passwords, starting with 1, 2, 3, 4, 5, 6, 7, 8, and then going up. All right, and if I want to see the whole attack, which I sort of do, I have 100 per page, that's good. So there's like 5 pages of it. So here it goes, 100 attempts. If I go to the last page, I'll see the end of the brute force attack. So here it is with password is Godzilla, Williams, and so on. And then down at the end, 46.51, 46.51, here is the last password in the brute force attack. And then there's a manual login later, several minutes later. So this is what you do. You run a brute force attack. It tries thousands of passwords. Then it reports, okay, I found the password. Here it is. Then you manually log in with that password to do things. So that's what's going on here. And this is the final correct password being used in a different format because this is a person opening the login page in a browser. The other one was a Python script, just sending automated requests that are not exactly in the same format. So that's the outline of the whole attack. And again, it's really nice how easy it is in Splunk to totally outline the attack here. And so I wanted to know the IP address of the attacker, was my immediate need. So now that I've got nothing but attacker traffic here, I can just get rid of this summary stuff at the end for now and see all these events one by one. And now I can see this is this is the final one with the person logging in manually, which might be different. Here's all the other ones are the automated attack traffic, which you'll see here. username is admin, and the password over on the right. That's what the Python script does. It puts the password on the right. So this is the attacker IP, the source of this stuff, which is going to be here, 23 and all that. So that's the attacker's IP address, which was my immediate attack. Then I want to know the executable file. Now, by the way, we're in a position to answer a couple questions from down here. You can find the first brute force password used. Now I've got the brute force password all laid out. And I can find the correct password, and I can find the time interval. So I mentioned these parts from section 3 are about the brute force attack, and they're easy to answer from what you've got here. Now I have the whole attack. If I return back to this, here's another thing I want to show you while I'm here. If you look at the HTTP method, the HTTP user agent, here, 412 came from Python and 1 came from Mozilla. So this is the automated script trying 412 passwords until it got in. This is the hacker attacking manually, so that's how you can tell them apart. Anyway, if I go back to the table, you can easily answer those other questions there. Now, if I sort them to make sure they're sorted by time, now I've got, this is when the brute force attack started, and it went on at the rate of several guesses per second. So it started at 14:45:21 and continued until 14:46:50, so about a minute and a half, to try 400 and odd passwords. And the automated guessing was done here. Then, here's the manual login later. There's the winning password, and this time interval is something they ask for as a flag. How long was it between the end of the brute force attack and the time the person logged in manually? And as you can see, it's 2 minutes and 15 seconds or something like that. So anyway, just thought I'd mention it. There's a bunch of flags you can find that way. And I think, I guess let's try doing the last one, the executable file the attacker uploaded to the server. Because what they did was, they did a brute force attack until they found the administrator password for Joomla. After you have that, you can now upload a file. That's how they got code execution. So let's go back. All we want to do is find common file name extensions. So what we want to have is the HTTP data coming into the server with, I think, was it the post method? I think it was. Find the events using the post method without the vulnerability scanner. So all this is the same thing we have now. And then I want to search for executable files. So instead of this, I can just put in like .exe. See if they uploaded an exe file. The other thing they might have used is a .vbs. But there are 2 times an exe file was referred to in a post method here. And so if I go down here, this looks like a directory. And if I go down here, here's a binary file going up. That's what it looks like, a whole bunch of unprintable characters. So this looks like the uploading of a binary file. And if you go down here, you'll find the name of the file. And I think it's just a number, which, by the way, if you're taking the hacking class, you'll get used to this. If you go to, like, ExploitDB, they give you files to use to attack servers to exploit vulnerabilities, and they just have a number, .exe. And that's what it's going to be here. Joomla, export, Windows NT. Somewhere in this mess, you'll find the file name. Well, I'm just going to look for .exe. It should be highlighted anyway, but the easiest thing is use Control-F for .exe there. There we go. There's the file name, 3791.exe, which are just, they're just databases. This is what, if you take 123, this is a standard hacking technique. So anyway, so I wanted to show you how to find a few more things about the brute force attack and how they got execution. So I'm going to stop this recording.